Resolving arguments with quantification theory. We have four rules by which you use to what? Resolve argument using quantification theory. We have the universal instantiation, which is represented with UI, universal generalization, UG, existential instantiation, EI, and existential generalization, which is what? EG. Now let's take them one after the other. For universal instantiation, which is UI. Okay. So now, what does this mean? This means that from a universal statement, we arrive at an instance. For example, if I say that let's say all philosophers, all philosophers are logicians. Okay, we can derive, we arrive at our conclusion that what? If Socrates is a philosopher, then Socrates is what? A logician. So you can see from a general word, from a universal statement or general statement, we arrive at what? At an instance. So all philosophers are logicians. So we arrive at our conclusion that what? If Socrates is a philosopher, then Socrates is a logician. Now let's symbolize this. All philosophers are logicians. How do you symbolize our universal proposition? X, okay? Philosophers, PX implies what? NX. Okay? Now, you can answer that if all philosophers are logicians, then because we arrive at a conclusion that what? If Socrates is a philosopher, that is PS, therefore, or let me say then, Socrates is a logician. So this is an example of universal instantiation. Okay? All philosophers are logicians. So you can arrive at a conclusion by saying that was, if Socrates is a philosopher, then Socrates is a logician. All philosophers are logicians, therefore, if Socrates is a philosopher, then Socrates is what? A logician. Let me give an example on let's go to our, before I give an example, let's go to our universal generalization, which is the second one. So for universal generalization, what does this one say? Or what is it saying? So universal generalization is saying that from an instance, we can arrive at what? General proposition. For example, this one means that what? From an instance, then we can arrive at a what? General or universal proposition. Now, for example, if Douglas being an atheist implies being rational. So we can conclude that what? We cannot conclude that all atheists are what? Rational. So universal generalization is that what? From an instance we can arrive or we can conclude our what? Universal, or we can deduce our universal proposition. So how do we symbolize this? You say if Douglas being an atheist implies being rational, so that means what? If Douglas being an atheist, that is A D implies what? Douglas being rational. R D. Sorry. R D. Then we can conclude that what? All atheists are what? Rational. So you can see the difference. This is universal instantiation and this is universal generalization. Okay? So now let's give an example. Let's go to the third one, which is what? Existential instantiation. The third one, existential instantiation, which is what? E-I. So what are we saying now? Existential instantiation. Okay? So for existential, remember, don't forget our universal instantiation, universal generalization. From a universal proposition, we can conclude that what, or we can derive our what, our instance. And for universal generalization, from our instance, we derive our what, universal proposition. So now, for existential instantiation, so for an existential, what does that mean? For an existential proposition, we can what? We can arrive at an instance. For example, you can see that okay, we can conclude, for example, we can see that color is a tyrant. Sorry. Color is a tyrant. Okay. Oh, sorry, let me start from some. Sorry. Some motorists are tyrants. Okay? Since Anna is a motorist, then since Anna is a motorist, therefore Anna is a tyrant. This is existential instantiation. As it's some, we can see that since Kola is motorist, or some, okay, sorry, let me do it this way. Some motorists are tyrants. Therefore, we cannot conclude, or we cannot deduce that what Kola is a motorist and a tyrant. This word extension is assertion is right there. From existential proposition, we can arrive at what? An instance. Now, how do we symbolize this? Some motorists are tyrants. Inverted EX. Motorists FX and what? TX. So, our conclusion now was some motorists are tyrants, then color is a motorist and it was tyrant. You can now say that color is a motorist, that's MK, and what? Tyrant, TK. That's it. From a particular, or let me say, existential proposition, we arrive at an instance. So now, the fourth one, which is what? Existential generalization. Which is what? EG. This is what? EI. So now, what does this essential generalization is saying? Or what's essential generalization is saying? This one is saying that from an instance, you can arrive at our what? Existential proposition. From an instance, you can arrive at what? Existential proposition. For example, if okay, let me, for example, okay, let's just use this. If Bertrand is an atheist and a rationalist, okay, so we can deduce that's what? That some, oh sorry, if Bertrand is a philosopher and an atheist, so we cannot deduce that what? Some philosophers are atheists. And let's symbolize. Bertrand is a philosopher. I was saying, since Bertrand is a philosopher and an atheist, we can deduce that what? Some philosophers are atheists. So that symbolize Bertrand is a philosopher, Abi, that is P, B, and what? Bertrand is an atheist, A, B. So we cannot conclude that what? Some philosophers are what? Atheists. Existential generalization. So now, these are the explanations of the 4 rules of quantification theory. Alright, so now let's solve 1 or 2 examples or 1 or 2 questions to understand better. Alright, so now for example, if we say that 1 we can infer, sorry, that we can infer that Jima is a tout because what? Because Jima is a matrix, and since some matrices are doubts. Now let's symbolize this. We can infer that Jima is a tout because Jima is a matrix, and since some matrices are what? Doubts. Initially, this one is that these are what? Conclusion. Okay? Jima is a matrix. Some matrices are what? Doubts. So these are our first premise. That's the premise 1. Some matrices, that is MS, are what? TS are doubts. Second premise saying that was Jima is a what? Matrix, that is MJ. Therefore, Jima is a tout. CJ. Now, we go to our line 3. Okay? Here, we said that we have the unknown, which is what? The S, Abi. But in our second premise, they've already given us what? The unknown that we are looking for, which is what? Jima. So, which means, we now say that our line 1 will now be what? MJ, for MJ and CJ. That is what? That's the line 1, existential instantation. Remember from our existential instantation, we say that what? From an existential proposition, we can what? We can arrive at what? As an instance. So some matrices are doubts. And in our second premise, let me say the matrices are the unknown there, which is representing this X, has been given as what? Jima. So that is what? That's our individual constants that we use to designate the subject term. Okay. Now, what? 4. Because we need to what? We need to prove how they get this conclusion. Remember, we are now manipulating quantification theory using what? Use of reference and replacements. We have MJ and TJ. Our line 2 has already given us what? Oh, sorry. As a mistake, this has to be a universal proposition. Sorry. Since all matrices, okay, that will be S. Okay, now this is universal instantation. Sorry. Now we can infer that Jima is a tout because Jima is a matrix, and since all matrices are what? Touts. Abi, matrices, all matrices are touts. Jima is a matrix, therefore Jima is a tout. Now MJ implies TJ. This implies this. And our second premise, we are already given our what? MJ. Therefore, our Line 4 now be what? TJ, which is what? Line 3 and line 2. Oh yeah. Modus ponens. So this is how we use the quantification theory to arrive at our to resolve arguments. Okay, now let's take another example. Another example, say that what there is no washable uniform. Let me say there are no uniforms that are not washable. There are no uniforms that are not washable. So that implies that what all uniforms are what washable. That will be X uniform are washable. Promise 1. And promise 2 is now saying that, okay, this one is saying that what there are no uniforms that are not washable. Okay, promise 2 is now saying that there are no washable velvets. There are no washable velvets. So that means what? All velvets are what? Washable. There are no, okay, this one is that there are no washable velvets. So this one is saying that what? No uniform, no velvets are what? Washable. The first one is saying that there are no uniforms that are not washable. Okay, that is all uniforms are washable. And the second premise is now saying that there are no washable velvets. That means no uniforms are, no velvets are what? Washable. Then the conclusion is now saying that what? There are no velvet uniform. There are no velvet uniform. That means no uniforms are what? Velvets. So you see that what? All uniforms are washable. No velvets are washable. Therefore, uniforms are what? Velvets. So now, our third line. What are you going to do? Use our universal instantiation. And there is one thing we need to take note of. Yeah, in a situation like this, that we are not giving the particular, okay, like this that we are giving Jima, okay, to designate this our unknown. In a situation like this that we are not giving the unknown to make use of y, and under universal proposition we can only use x and y. But if it is extension instantiation, you can use any variable to represent it from a to w. But for universal proposition, x and y. Now we have ux implies wx. So if you want to use our universal instantiation, it's now be uy implies wy. That is line 1 universal instantiation. Line 4, the same thing. Vy implies not wy. That is line 2 universal instantiation. Now what are we going to do here? Because we need to arrive at our what ux implies not vx. The first thing we need to do here is we are now manipulating our use of reference and replacements. Now here, line 4, what are we going to do? We use transposition. That will give us not wy implies not vy. So that is line 4 transposition. Line 6, not wy is same thing as what? Wy implies not vy. That is what? Line 5 double negation. Now our line 7. Now, line 7. Now, in our line 7 now, we have, now line 3, we have uy implies wy. And this wy is already implying another thing in our line 6. You can now say that what uy implies not vy. That is what line 3 and line 6 hypothetical syllogism. In our line 8, you now be what? Remember, in our universal generalization, that one is saying that what? From an instance, we can what? Derive our what? Universal proposition. So this is an instance. You can now see that ux implies not vx. That is line 7, universal generalization. You can see we've already arrived at our what?